multimodality is going to help. We kind of built a question answering dataset on top of it. Once the LLM has created these question answers, we have to verify.
Hey Gowthami, thanks for agreeing to do this interview. Welcome to One Little Coder podcast. Can you tell us about yourself?
Hi, thank you for having me. I'm a PhD candidate at the University of Maryland. I have mostly worked on multimodal models for the last few years, especially memorization and diffusion models. Over the course of last 1 year, I have been working on video LLMs, trying to get the lay of the field, like where do these models work, where do they don't, and trying to contribute in the open problem areas and so on.
Can you tell us more about your background? Like what did you do before you arrived at this place?
I have a quite non-conventional background. So I actually did my undergrad in mechanical engineering, and then I worked for around 7 years in India in mechanical engineering related roles, and then I had a startup, and in fact that's when I started programming. And then I worked for a year or so at Flipkart. I wanted them to give me a tech job, but they said I didn't have a CS degree, so they gave me a business related role. But still I was feeling this unhappiness inside me that I want to continue working on machine learning. I want to do some programming. And that's when I just applied to master's program, in fact, in Maryland, because nobody would take me as a PhD student with my unconventional no coding background. That's when I started Maryland, and I really enjoyed doing research there. I feel UMD is one of those schools who are open to even letting master students do research. The profs are kind of quite open. Anyone who wants to do research will get an opportunity to do research. So I got lucky, and then I converted from master's to PhD program, and here I am.
Oh, that's really great. And see, you could have continued in the mechanical engineering route. What made you interest, let's say in today's environment, LLMs? Why are you in LLMs?
So first of all, I never saw myself. I mean, first of all, LLMs were not a thing when I started the program in 2019. At the time, all the rage was vision models, and especially GANs. I mean, LLMs is a sort of a niche subfield, a bunch of NLP researchers were doing, right? I feel I went with the flow rather than trying to say, okay, fine, I will do only this one thing. And for going back to your question about why I switched from mechanical engineering is honestly it was not a plan. I started up. That's when we were a small team, and I had to help out my technical co-founder with programming aspects, a few things, small things, initially setting up with the web page, or writing a little bit of code snippets to understand the customer behavior and things like that. That's when I actually got started. And then I realized I mean, programming is a lot of fun. I mean, when I compare that to the work I was doing in these companies, it's mostly managerial roles, which kind of are not intellectually challenging, at least for me. And that's probably why I pursued this route. Again, it's not a plan. It just happened. I just happened to be in the right place at the right time, I guess.
Yeah, that's nice. And I hear from a lot of people who say that, I miss the old non-AI days where, GANs were there, people are building deep learning models. And now it is a completely different thing with LLMs. They're ruling the space. Do you miss the old days, or you are happy with the current LLM space?
There are two things. I'll talk from both sides, honestly, because I mean, depending on the day, I feel differently. From the pro side of the current trends is a lot of things happening, really, really fast. And there's a lot of access to these tools, or even repositories. There's a lot of open source repositories which are available now, which were not there 3-4 years back, honestly. And that aspect's great. We are moving really fast, and then we are building a lot of things that actually work. That's fun. On the other hand, I feel there's just so much happening, and at the same time, very little is also happening. I mean, for example, if you see vision LLMs, I would say that at least 200-300 models are there right now, like probably a bunch of them, even open source. But unfortunate thing is, all of them are kind of following like same set of recipes. They're all training on same data sets. Most of these models perhaps change like the kind of vision encoder they are using, or LLM they are using, or the connector module they're using. I mean, honestly, this feels like more of like an ablation to me rather than like a completely new paradigm. And I wish like people are a little bit more what do you say, brave in terms of trying out ideas rather than like take a working recipe, like make a slight difference and like write a paper. That's what I'm slightly unhappy about, because I kind of like read a lot of papers, kind of come out very disappointed at the end of it, like as if I haven't learned. But that was not the case like 2-3 years back, where I take a paper and read it, like I definitely feel satisfied at the end of it. Okay, sorry for the rant.
No, that's
Yeah.
completely fine, and that gives a really good segue. A lot of papers that I read, like you said, it's an ablation, it's an improvement on something that exists right now, rather than a paradigm shift. But one of the reason I'm talking to you today is that you built an amazing data set called Cinephile, and it is, I would say that it is again not a very conventional path. Like I don't see a lot of people building a data set. What motivated you to start with a data set in the first place?
Actually, I did not start with a data set. Honestly, like I was working on diffusion models like before last summer, and I was interning at Meta, and the team I was working on was like a video understanding team. They wanted me to do something around the video LLMs, and I mean, it kind of like I was always about in. I mean, I always thought like we kind of have these artificial separations of like vision and language, but I always felt like true intelligence will come when all the modalities are merged well. And typically, like multimodal models are typically the way to go to achieve true intelligence. And again, a digression, like a video LLMs kind of gave me an opportunity to just jump into that space and like try to get to understand the lay of the land. So I started reading a lot of papers at the time, and then I kind of noticed like a couple of issues. First thing is even like around August last year, there were a lot of video LLMs. And I realized that most of them are built on top of like one or two data sets, web video, a 10 million, which has like captions from Shutterstock, and a couple of other small scale data sets. Okay. And most of them are caption data sets. That means like caption datasets are typically describing like what is there in the video rather than try to understand like what is happening in a video. Like when we humans watch a video, we kind of don't pay attention to what clothes the person is wearing, but we are more interested in what is their motivation, or how they are feeling, or where what might have happened before this video and what would happen after this video. So there's like a lot going on like when we watch a video. However, the data sets out there are currently out there right now are quite descriptive in nature. So I felt like there is a gap there. Honestly, like I wanted a data set to build a model which will do true video understanding. However, data set did not exist. So I had to build a data set first. So that's where the inspiration for Cinephile came. I was reading like a few papers at the time, which is one of them is from Oxford, this paper called Auto ID, where they were kind of trying to do like movie descriptions on top of like this another data set called MAD. So I felt like that could be like a good starting point for us to build like a true understanding video question answering sort of a data set. That's where the whole motivation came from. I hope I answered your question.
Yeah, absolutely. And can you give us like a very quick primer about what is Cinephile for people who do not know that?
Cinephile is a long video question answering dataset. For non-video people, typically would think like a long video would mean something like an hour. However, in video understanding land, like anything more than 30 seconds was typically considered as long video, like at least like until last year. And most of the video datasets which are out there are typically like short in duration in nature. Our dataset is mostly focused on like clips from the movies, which are like typically these movie clips are like 2 to 3 minute long. And they're self-contained. Like for example, like a particular scene, like an important scene that happens in the movie, we kind of built a question answering dataset on top of it. Like for example, along with the character, we have like a bunch of descriptive questions as well. Like for example, what is a particular character holding, or who are they talking to, or where are they walking, what kind of clothes they're wearing. On top of it, along with that, we also have some sort of understanding questions like what is the theme of the whole scene, like is somebody scared, or is somebody happy, or is it somebody proposing to his girlfriend or something like that. We focus on like try to understand like more comprehensive understanding of the scene rather than only descriptive understanding of the scene. So we built like a lot of questions on top of it. So the data set contains like both train and the evaluation splits. Like train split has around like 300,000 question answers, and evaluation split has like around 5,000 question answers. And we kind of built like the whole thing with like with LLMs primarily with human in the loop sort of a thingy that kind of helped us like scale it to like this large scale without like a lot of a cost and human intervention.
Yeah, can you also describe the process, because you said there is a human in the loop
Yeah.
and there was LLM also helping. Like, how did this entire data set come about?
Most of the previous video understanding datasets we noticed are mostly like written by humans. Like you kind of make a person watch a video and then ask them to write questions. Like so, this sort of approach is not quite scalable. So what we thought is, given good human raw data, like written by humans, we have like this set of powerful LLMs which can turn that text information into question answering information or comprehensive understanding information on top of which we can build question answers. So that's where the whole the secret sauce of the paper is. So we started off with this data set, which is just audio descriptions. Audio descriptions are nothing but for the visually challenged people. There are movies typically come with audio descriptions, like where they wear the headset, the dialogue goes on, and then in between the scene, like people try to explain like the lay of the scene. For example, like a character is running, or a person is feeling scared, or somebody is like angry, or for the blind people, basically. Like so this is all done on volunteer basis. Like for maybe you have like a family member who is visually challenged, so you want to contribute to this whole data set so that they can enjoy movies as well. This data set is quite valuable in nature because whenever a human is annotating or saying certain thing about their scene, they're using their biases. They're kind of trying to prioritize only the important elements which are needed to understand the scene. Like they're not explaining a woman is wearing red dress unless it is important to the scene. Saying like, okay, fine, this she's wearing, for example, like maybe she's wearing a black dress because they're mourning someone, like it's a death related scene, something like that, right? Like so the humans will describe only the descriptive information only if it's relevant. That's what the idea behind the data set is. Like with this very valuable human generated raw data, we take all of this data which contains like human descriptions along with the audio descriptions. So with and this complete text in this audio data is completely is sufficient to understand what's happening. Now we take this and then we use LLMs to actually like try to turn that into like a question answer. So for GPT-4 is like quite good at it. Like it can understand like long pieces of text. Like we just had to prompt it really well. We had to try out like a lot of variations, but however we got the right set of prompts and we pass this raw data which is in the form of text, like with which subtitles as well as the visual descriptions, and now ask the GPT-4 like, okay, fine, like try to create us like this sort of questions for us.
The GPT-4 part is the LLM part, and the human in the loop part is the volunteer annotators who actually created the audio description of the video that you described.
No, actually, like there is one more step where once GPT-4 so human in the loop is like we coming up with the prompt ourselves, and that is the human in the loop part. And also, like once the LLM has created these question answers, we have to verify like if there are certain set of biases that are being there, right? Like I mean, LLMs are not perfect yet. Like they still have some issues. So sometimes like they don't generate the questions well. Sometimes they generate like regenerate questions. We sifted through like a lot of data to actually try to understand the mistake patterns in these questions that are being generated. And we kind of what we did is we built a filtering pipeline. Like one, we get the questions out of GPT-4, and now we have to filter them out. We can't use all of them because there are some useless questions. Like let me give you an example from the paper. There is a question like, what is the hair color of blonde woman? I mean, like that's a redundant, like blonde. It's literally there in the question. So these are useless questions. So which we don't need any scene information to answer them. So human in the loop part comes out like where, for example, like coming up with the prompt or building these filtering pipelines. Like after we understood like what are the mistake patterns, and we kind of built a filtering system to remove those questions.
Just because you brought in a blonde woman in the example, and we have seen like especially proprietary LLMs like GPT-4 kind of evade the questions that are let's say ethically that is somewhere in the gray area and these things. And when you talk about video description, there are a lot of these kind of cases that would come, like for example, like a white woman, blonde woman, a black woman, and all these things. Did you have any issue with using an LLM for this kind of thing, or like that was not an issue at all?
One issue we faced is for the hair color or human descriptions, we did not face too many issues because the person who is narrating also kind of tried to keep it safe and appropriate. We faced like some issues with some scenes, especially like with violence, because there are some horror movie scenes also, like in the data set initially. The model said, okay, we cannot process or create questions on this set of descriptions. So yeah, that was definitely we had to remove like some scenes, not just because like LLM denied to answer, but also because like we wanted to keep the data set like slightly appropriate in case like people want to train their proprietary models on top of this.
Let me just quickly summarize the process. So you started with the voice description, then you used LLMs to create questions. Human is there. Then there is a filtering system in place, and at the end of the day, you have got train data and let's say tester eval data. So is that the end process at which you publish, or like there is something else that I've missed?
Okay, one more point is test data we have completely validated manually all 5,000 questions just so that there are no mistakes in the evaluation. We tried our best. We looked through all 5,000 questions. In fact, like the first author, Richard, he did a great job. Like he kind of spent insane amount of work like sifting through these. We manually verified. Like test set is manually verified also. That was where we kind of published a paper. We evaluated our bunch of off-the-shelf open source and closed source models also on our benchmark, and yeah, that's about it.
So when you say you evaluated it with bunch of LLMs, is it
Yeah.
more like using LLM as a judge, or like how does this process?
Our dataset is question answering dataset. Each question will have like 5 answers, completely accuracy. It's not LLM as a judge. The model has to output like one of the options explicitly, or it has to output A, B, C, D, E, one of these things. This is 100% like we compute accuracy. One tiny issue currently with open source models is they're not so good at instruction following. That could also be contributing to why their accuracies are significantly lower compared to like a proprietary model. Yeah, we are not using any other system. This is not subjective metric, more objective.
And when you say you used open models or like proprietary models, did you actually give the video clip and ask them to answer, or is it like just text and then answer?
We kind of evaluated them completely with video or vision components. So what we do is when we are evaluating the models, we kind of just assume only the video input, okay? But video, you can break it down into a bunch of images plus subtitles. I mean, like right now, most of the proprietary models other than Gemini don't process video natively. I guess like GPT-4o is supposed to. We had to like break it down and evaluate, or we pass the raw video. Sometimes we pass video as well as the subtitles and so on.
That naturally leads me to my next question. You mentioned
Okay.
GPT-4o, which would probably natively process video. Gemini 1.5 Pro, at least I've personally been very impressed with how it processes video.
Yeah.
And Meta came up with Chameleon very recently, a multimodal architecture.
Mhm.
Do you think your data set would ultimately end up contributing to better open source models that would natively process videos? How do you see this direction going?
Good question. Gemini Pro, we are very impressed by it too. It kind of performed really well. GPT-4o, I don't know about now, but like a couple of weeks back, at least, like the API is not accepting videos natively. Chameleon, again, like it's not open source, so we can't. There are no multimodal models from Meta yet. For your question, how our dataset will contribute is, first of all, there is like a lot of gap between like open source and closed source models. We are hoping like our dataset could help bridge that gap in terms of video understanding or instruction following capabilities. Both like our model could help bridge that gap.
Honestly, in today's environment, if you go on Twitter, it is very easy to build, let's say, a fine-tuned version of Llama, get like 0.3% or 5% improvement in MMLU, and everybody is going to be like, oh, this is the best model, this is quite amazing. But you have done a foundational work, very similar like what did ImageNet do in that era. How do you see the reception of what you have published versus, making another choice of building another model that would improve benchmarks?
Okay. So it was surprisingly the reception has not been too warm. I really expected people to be more excited about it, but yeah, people are okay. I don't know. Like I feel like Twitter is slightly skewed perception of things might not be what community is actually thinking about. There are a lot of practitioners on Twitter right now, like LLM practitioners especially, and these people are. I think LLMs are kind of like a research of now, right? Like they have immediate applications. However, people don't see too many applications for like multimodal systems or video language models. So there are fewer people thinking about it compared to pure LLMs. However, one thing I noticed is it's still like people were quite excited about it, and I got like few things about like that they're excited about the data set and so on. These are problems of tomorrow rather than today. So I mean, I don't know. Like, did that answer your question?
No, it does answer. Like honestly, like one of the reason I wanted to have this interview is because I know a lot of people get excited about like another new model, whether people use it or not. Like every time a new model comes in, like everybody is so happy. But I think like the credit that people like you and your team that build the foundational, that contribute to foundations, I don't think like it is at the same virality or level at which these kind of improvements happen. So that is primarily one of the reason like I wanted to have this conversation, make this awareness like within my community that these people are actually contributing to the foundation. Maybe 2 years down the line you're going to get like state of the art like multimodal model, and somewhere like you have contributed to that, and I want people to understand that and do more of this work when we get out the word. So I'm happy that you're sharing all these details. The one thing I wanted to touch upon is people have started realizing that maybe we have hit a cap with LLMs just purely as a language, and true multimodality, whether we speak about AGI or not, that's a different thing. But true
Sure.
multimodality will exploit the true potential of AI. What is your opinion generally about it?
Yeah, I'm totally in that camp. I'm not saying like we are anywhere close to true intelligence. However, if you want to improve the performance of even current systems, I feel like multimodality is going to help. Honestly, humans are visual creature. All the modes come next to us, right? Like we are perceiving the world like primarily as vision. So definitely, like building multimodal systems will in fact improve the language models as well, in my opinion. Like even the text systems as well. Like because both of them are quite related, and there is so much we are missing out on. Like there is a lot of video information which has text as well. Like I mean, of course, you can if you convert the audio into text, and there's so much more going on compared to just pure language. So we need to think, and one issue I see right now is everybody is kind of thinking as a vision or audio as second class citizens with like language as the first class citizen, and we will of course hit like a limit of how much you can do thinking that way. You need to I feel like we can cross that barrier only by kind of building truly multimodal systems where you are thinking of all these modalities together as first class citizens, and trying to make the models understand slightly harder questions, like rather than surface level, right? Like I said, as humans, like we when we see a video, the first thing is like, what is this video about? Like we kind of build our own priors and then we change them along the way. However, right now the systems are like, what is the woman wearing? Where is the car? I mean, these are very surface level. We need to dig deeper and build good data sets, train models like with treating all modalities as first class citizens. I mean, there are some attempts which are being made in that direction. Like for example, Unified IO from LNAI. It's not too famous, unfortunately, but I think like that's a good model, like in my opinion, which more people should know about it. And yeah, people are starting to think that way, and I'm hoping to see like yeah, excited about like seeing more models. So
Is there anything particularly you're excited about the future, like new architecture, like multimodality, like anything that you just want to see?
so I mean, the one thing I definitely want to see in the near future is stop thinking like diffusion models and video LLMs are separate things. They all should come together. They are literally only one thing. And we should be building these any to any sort of systems, especially like video models. Honestly, like I was very excited when I saw Sora, and especially in fact, like I was also very partially because the way they titled it, videos as like world modelers or world learners, right? Like that is very true. I mean, they took like a first step towards the direction. Videos are truly multimodal. There is like language, there is vision, and there's so much going on, like information, right? Like we need to build more natively video understanding systems, both in terms of like, yeah, natively like multimodal systems, which can generate text, generate image, generate videos, process text, everything to anything sort of systems.
Yeah. Just before we wind up, if somebody is starting out, let's say like a normal engineer, like a CS engineer or some other engineer, and if they want to become, let's say, AI engineer or like LLM engineer, what is your advice for them?
Just start building. That's the only advice. Like, honestly, AI or ML is kind of there's so many resources out there right now, which is great. Like, honestly, anybody can just get started and pick a project. I would suggest like pick something you care rather than going after a fad. I mean, LLMs are great, but if you don't really care for LLMs, you will never become an expert in LLMs. Or, I mean, like not LLMs. LLM is just a tool, okay? Like language understanding or language generation, that should be your goal. And LLMs is just a way to achieve it, right? So yeah, pick something you're passionate about and then start building it, because passion is literally the only thing that will keep you going. And it's very hard to motivate yourself, because like there are a lot of things don't work and you will see a lot of failures unless you actually believe in the mission of what you're working on. Like it's hard to keep going in this current world.
That is a really great advice, and thank you so much, Gauthami, for all the insights that you gave. I truly enjoyed this.
Thank you so much, and thank you for the invitation, and thank you for like highlighting our work.